it's magical. Let's do question 41. It's a story about a girl and a boy. You have a girl riding a bicycle at a constant velocity of 3.5 meters per second. Every 1 second, she can, in the bicycle, move 3.5 meters. At time t equal to 0, she passes a boy sitting on a bicycle that is stationary. So this is a boy. At time t equal to 0, the boy set off to catch up with the girl. He accelerates uniformly from t to 0 until he reaches a speed of, so he goes to VD equal to 5.6 meters per second at a speed at a time of 5 seconds. He then continues at a constant speed. So this is the first phase, the second phase, VB2. He goes at 5.6 meters per second. At time t equal to t, the boy catches up with the girl. So when time is equal to t, both the boy and girl actually catch up and meet up with each other. T is measured in seconds. The boy and the bicycle have combined mass, so you have a M boy of 67 kilograms. A. Calculate the force required to cause the acceleration of the boy. So they want you to find force during the acceleration. So in this case, let's do the question here. We talk about acceleration of the boy. Let's draw a UV set line. U equal to 0, V is equal to 5.6 meters per second as a t. So we want to find acceleration. Good thing is time here is already given to be 5 seconds. We got 3 information, so we don't need this one. So acceleration, which equation has u, a, t, and v, which is the second equation of motion. A is equal to v minus u over t, also known as the defining equation of acceleration, which is, in this case, v is 5.6, u is 0, and you got t equal to 5 seconds. I don't have to calculate with me, so please calculate this. By the time you have calculated this, you should have an acceleration of 1.12 meters per second squared. Now, you want to find what is your force. Resultant force is equal to MA 67, 1.12. So, this calculator, hopefully when I pause this video, you should have a value of around 75 newtons. Then, moving on to the next question, V. At a speed of 4.5 meters per second, so the total resistance force acting on the boy, so this is about the boy when he is at 4.5 meters per second. The total resistance force, so this is resistance force, is equal to 23 newtons, that's acting on the boy and the bicycle. Determine the output power of the boy's legs at this speed. So what is the boy's output power going to be? So let's begin this. We have power is equal to work done over time equal to work done creates energy over time equal to force times velocity. In this case, we have velocity, we have 23 newtons. So, most obviously, you'll be using force times V, but we have a problem. Resistance force is 23 newtons, 4.5 meters per second. When we do this, we usually assume that this is constant speed. So if this is constant, what would be the true force that's actually required when the boy is at the speed? Again, what do we have here? The driving force. Okay? We have then a driving force. To to cause the boy to accelerate. In order, here we need to find the total force. So the total force here, in this case, should be the resultant force to propel him forwards. We also have the speed that he is when you have a resistive force of 23 newtons. First, you got the force required to propel him, the power that you need to do this, to actually drive the cyclist, the bike on the road. Then you have the resistance force of that times your 4.5. Again, remember, we're trying to find the power output of the boy. In order for cycle to move, it will require this amount of driving force, but he also has to go against friction. That's why we add it together times 4.5. So you have two forces in which you need to actually put in energy. Okay? Then hopefully you can calculate that, and hopefully you get an answer of around 440 watts. I hope you understand the video. If not, please replay this video.